Jack Andraka, a young scientist, an inventor, also a student, 17 years old. Thank you so much for being with us.
Thank you so much for
You
having
developed
me.
a great idea, an early detection test for pancreatic cancer and other types of cancers. Tell us a little bit about that idea.
Yeah, so essentially what I created was a new way to detect pancreatic, ovarian, and lung cancer that costs 3 cents and takes 5 minutes to run. This makes it 168 times faster, over 26,000 times less expensive, and over 400 times more sensitive than our conventional methods of detection, but also can detect the cancers in the earliest stages, when something has close to 100% chance of survival. And so far, it has over 90% accuracy at detecting those cancers. But one of the coolest things about this sensor is it can be rapidly applied to really any disease, ranging from Alzheimer's, other forms of cancer, even HIV, AIDS, and heart disease. The possibilities are pretty much endless for it. So that's what my 9th grade science fair project was about.
And you were only 15. Why do you think this wasn't done before?
It was really being at the right place at the right time. And that's what all science is about, is being at the right place in the right time with the right mentality. And so I was just sitting in my high school biology class, listening about these certain types of molecules that only bond with like certain proteins in your bloodstream that are found when you have these cancers. So we were learning about these. And then at the same time, I was reading an article about single-walled carbon nanotubes. And these are essentially these long, thin tubes of carbon that are an atom thick, and they're 1/50,000th the diameter of a single strand of your hair. So they have these amazing properties. They're kind of like the superheroes in material science. Like they conduct electricity better than copper and are stronger than steel. I mean, they're simply amazing. But their properties had just begun to be understood. I mean, the Nobel Prize was awarded for their discovery in 2008. And so that just really speaks to the recency of how these nanotubes are working and how to make them really cheaply. And so these two technologies were kind of coming together at the same time. This massive influx of new proteins that we find in your bloodstream when you have these cancers, as well as these carbon nanotubes. And there I was caught in the middle in my high school biology
That's when
class.
you had your Eureka moment.
Exactly, and it's a pretty unlikely place to have a Eureka moment in high school biology class. Probably the stifler of innovation, but it was still really cool when I had that moment.
And yet that was the lab where you were able to begin your research, your high school lab, if I'm not mistaken.
Yeah, so I began doing some preliminary tests in there, and once I saw maybe there's something to this idea, I got 199 rejections. And I only got 1 acceptance from Dr. Andraka at Johns Hopkins University.
Were you losing hope?
I was absolutely losing hope. I mean, I was like, well, maybe this idea doesn't work. I mean, I could take my parents telling me no, and my biology teacher, I didn't like her, so I was like, all right, whatever. But 199 of the foremost experts on pancreatic cancer saying, this idea isn't going to work. I mean, that was really harsh for me. I mean, these amazing people are saying this idea is terrible, Jacqueline.
Do you think there's a prejudice or some sort of discrimination that knowledge is just supposed to be owned by very, very few, and if a 15-year-old has an idea, then it's immediately discarded just because he's too young and inexperienced?
I mean, there definitely is that kind of mentality in the scientific community. There's kind of this rite of passage that you have to go through, like the standard bachelor's degree, as well as a PhD or an MD, and maybe even more like as postdoctorate. And that there's just this incredible time barrier to being able to do science. And I do admit that extra knowledge does come in handy, but at the same time, the ideas of the youth are some of the most innovative and creative ideas, and to just discard those, that's just a waste of human capital. And so for me, it would be really amazing if you could combine the ideas of the youth and the knowledge of the old generation.
So to be an innovator, do you learn how to be an innovator? Are you born an innovator?
There's this one quote, I think it was from Picasso, that's like, all children are born artists. It's only maintaining their artistic talent and creativity. And that really speaks to innovation in general. Everyone's born an innovator. Everyone can be a scientist, an engineer, an astronaut. It's just a matter of keeping that creativity, that drive, that passion. Because science is incredibly interesting. I mean, what isn't cool about learning that, hey, we're made of the stuff of stars, or hey, I could find a new way to detect pancreatic cancer. I mean, that's simply amazing. And
is it a great idea, a great execution, or both?
Both. You have to have not only a great idea, because everyone can have an idea. it's execution that's particularly key. So it's kind of this joint thing between the two where you have to have both in order to succeed.
Do you think our schools are doing enough to promote innovation? Are our companies doing enough to promote innovation?
On the education side, I actually think a lot of school systems are actually detrimental to creativity because we have all these standards and we're teaching to standards, but people aren't a standard. We're unique individuals who each have our creativity and talents that we bring to the table. And so I think that we're really squandering our human potential by saying you have to meet this standard, and if you don't, then you're considered a failure. I mean, this kind of like factory mentality is really ridiculous and outdated. And
what can we do to change that?
I think in order to change that, we have to allow kids to be able to explore and be able to have hands-on activities and really take back their education. And I'd like to call it hijacking their education, because by doing so, letting kids explore, not only does information stick so much better and the kids are more interested, but also you're enabling all these kids who previously couldn't innovate and couldn't contribute to the scientific discussion to be able to talk and innovate and come up with great ideas in the scientific world. What's necessary for innovation is not only do you have to have the time to think up of an idea, you have to have the creativity and also the knowledge to make all of them happen. You kind of have to have this perfect storm, and that happened for me because I was a high school student, so I had a lot of time. I kind of knew a lot about all of these different things relating to cancer, carbon nanotubes, and these antibodies. And then also I kind of had this flash of creativity just because of my youth.
How important are government policies, legislations, to promote innovation?
So governmental policies, particularly how it relates to patents, are absolutely crucial because patents are one of the main driving forces of innovation. They provide this instant incentive to innovate. And also, in order to make an innovation carry on to real life applications from bench to bedside, really for the medical applications, you need to have so much investment in terms of financials. And in order to have that, you have to have these patents. And if you don't have these patents and trademarks and intellectual property laws, then that'll just fall apart and there will be no investment from the private community. And thus we won't be able to get technologies to patients or to the world as fast as we could if we had these different intellectual property laws.
When we think about innovation, we think about science, we think about technology. Do you think innovation needs to be more spread out through the industries?
Definitely. And there's this whole movement about that called STEAM, where it's all about STEM, like science, technology, engineering, and math, but combining it with art. Because the two are kind of complementary in each other. I mean, innovation in art is just as important as innovation in science, because science at times, it can be cold and unfeeling and lack that human connection. That's where the art comes in and makes it such that it has that human connection, where it's easy to use, it's simple, it's painless. And by marrying these two concepts, we come up with the solutions to the next world's problems.
And it seems to me like innovation needs to be spread out also through the population. If innovation stays in the hands of very, very few, it doesn't really push for economic progress of a country. What's your view on that?
Yeah, so innovation, it's kind of the same as money. When you hyper-concentrate wealth in just a select few, that's not really good for GDP. I mean, there's countless studies for that. The same is true with innovation. When you only have a select few able to innovate, that's not as great as having all these people innovate, because only 5 people versus 5 million people, I mean, the 5 million people will beat the 5 people no matter how smart they are. And so I think by having us work as a global team, as a global community, working together for scientific progress, that's when innovation will really start to come.
And when you have an idea, economic progress does not happen at the moment of invention. So are we doing enough so that once the idea is there, we teach workers to implement that idea? We teach students to implement that idea, families to implement that idea?
Absolutely. I mean, I've seen so many of my friends and peers and colleagues have amazing ideas, world-changing ideas, but they don't know the next steps to take in order to lead that idea to fruition. But also it's a matter of once you've kind of had a proof of concept of your idea, bring that from there to the real world And bridging that gap is, a lot of people underestimate how hard it is to bridge that gap. I mean, it's a huge gap being able to get like a technology accepted by the populace. And so teaching people, especially scientists and research scientists, how to bridge that gap and how to communicate their ideas to the public, because communication is key in scientific research and being able to bridge that gap. So teaching them not only how to go from idea to proof of concept, but also proof of concept to real life applications.
What do you tell kids that think that they need to get a PhD before they can call themselves innovators?
I think the notion of you have to have a PhD to innovate is ridiculous. I mean, definitely a PhD, like it helps you with all this knowledge and stuff, but at the same time, you can innovate regardless of your age or gender, where you're from, or how old you are, or what degrees you have. You don't have to have letters behind your name in order to innovate. It's your brain that's doing the work and your creativity. And all of us have that in ourselves. And combined with the internet, we have both the knowledge and the creativity. And with those two, we can make anything happen.
Thank you so much, Jack.
Thank you.